Good morning and good day, everyone. Welcome to the inaugural tinyML Technical Forum Asia. I'm Dan Su. I am an assistant professor in Shanghai Advanced Research Institute, Chinese Academy of Sciences. It is my pleasure to welcome all of you to tinyML Asia. My pleasure to introduce Evgeni Gousev from Qualcomm Technologies, and he's the co-founder of Tiny Machine Learning Foundation. His presentation is Big Opportunities for tinyML Applications, Everywhere and Always On. Evgeni Gousev is the Senior Director of Qualcomm AI Research. He leads Qualcomm Research and Development Organization in the Silicon Valley Center. He is responsible for developing ultra-low power embedded computing and machine learning platform, including always-on machine vision. He was a research assistant professor at Rutgers University and lead projects in the field of advanced silicon technologies at IBM. He earned a PhD degree in the solid state physics and master in science in applied physics. Let's welcome Evgeni. Yeah, Evgeni.
Thank you, Rudan, for the introduction. It is a pleasure to be here. I think we're going westwise, right? So Jan started in Amsterdam, and then Matt joined us from. I'm broadcasting here from the San Francisco Bay Area. So I think we're getting close to China. And while it's dark here, good morning, China. Good morning, Asia, and hello, the rest of the world. So today we'll be talking about applications of tinyML. Just like Matt and Jan, I'm a technologist deep in my heart. So I love to develop new technologies, new products. It's a lot of fun with my team. But today we'll talk about applications. And the reason for this is because when we talk about tinyML, the technology and the software and the algorithms are really, really cool and very interesting, like Jan and Matt given us a nice overview of the state of the art. But what keeps me especially excited about tinyML is the vast majority, basically the ocean of application. It's endless what you can do with tinyML, and that's what we'll be talking in this application, in this presentation today. So I'll cover these topics. We'll start with the fundamentals, because the fundamentals really fundamentally drive the value and the nature of the applications in tinyML. Then we'll talk about some specifics, markets, and the value of tinyML in these markets today, and how much it's going to be created in the near future. So then it will be followed by examples and specific applications, and you will see there that indeed the applications there are so plentiful and so enormous. It's just mind-blowing what you can do with this tinyML. And then at the end, I'll give some examples of the products we develop in the tinyML area in Qualcomm. Okay, so let's start with the fundamentals. So the way we see tinyML community, tinyML ecosystem, and how it's going to evolve in the next few years is shown here. We see a new world with like trillions of intelligent devices. They all will be enabled by this tinyML intelligence, the technologies that sense, analyze, and anonymously act together to create a healthier and more sustainable environment for all of us. So as you can see from this vision, it's really, the scale is enormous, but also what is more important, the impact, the healthier and more sustainable environment for all of us is really what makes it outstanding. And I hope that at the end of the presentation, you will have a better feel of where this community, where this ecosystem is now, And again, all this enormous opportunity that it is going to create for all of us in the near future. Let's start with the definitions. I think Jan and Matt already gave a good description of what tinyML is. So this is kind of my view of tinyML. We all live in a physical world. What you see here on the left, that's my dog, the analog creature that plays in the analog world, in the physical world. And then yet we are increasingly living in the digital world. And the fact that we meet on Zoom and Bilibili instead of in Shanghai, that's just a manifestation of that we are getting more and more in the digital world, whether or not we like it or not. The way these two worlds are connected, we have sensors on one hand. The sensors, they analyze analog signals from the ambient, from the environment, can be vision, can be audio, can be any kind of environmental sensor, chemical sensors. And this small device, the transducer, it transforms this into digital signal, and we have a microprocessor here, and that's what Matt described in his overview presentation here. And then at the end, we have a set of ones and zeros, kind of the digital signal that goes either to the edge or to the cloud. And that's where you typically do AI today on the cloud. So we know that this approach works, but it's extremely energy inefficient. It has privacy issues, it has latency issues, and it has reliability issues. So it definitely has some fundamental deficiencies. And that's where tinyML comes to play. So what happens in the tinyML world, so we have a set of technologies right here, and that's basically we do machine intelligence right in the boundary of the physical and digital world. So instead of sending tons of ones and zeros to the cloud, all the analytics, everything happens, all the action happens here. And that's why tinyML is so powerful, because you can just do so much where the physical world meets the digital world. It's extremely powerful value proposition for all technologies, and it's going to create a lot of big applications in this space, and that's what we are going to review soon. And from the technology perspective, this is the most efficient, energy efficient way to do analytics. It it does privacy by design, because the output of these devices typically is metadata, so not images. It has the best, fastest latency, and it has no connectivity issues. Again, fundamentally, this is the best way you can get machine intelligence close to the physical world. And kind of the way we define it, it's a set of technologies, architectures that can do on-device analytics at milliwatt power and below. It's basically the same one that Matt described earlier. So I think why we believe that tinyML opportunity is so enormous. So I think that the answer is quite simple. So we live in the digital world again, and the data is a new oil and or new electricity. And if you believe so, then the machine learning is a way to produce this data. And talking about the sources of data, if you look at where the data sits, the cloud ML, that's kind of the most popular ML today, it has only 1% of data. So it's only 1% of oil is actually on the cloud. And you have machines like TPU and so on that can help to deal with this data. Then one level below, we're talking about HML, like a typical example would be like a smartphone or Alexa type of device. So there you can get 4% of the data. It's bigger, but if you look at the real physical world, 95% of the data, so the vast majority of the data, like again, 95% of the data is in the physical world, in the real world, in real time. And that's where tinyML is. tinyML really helps to extract all this massive amount of data in the physical world and make it work for you, make it work for good things. And in terms of hardware, talk about like CNN micro type of architectures and MCUs with hardware accelerators described in Matt's presentation. So at the bottom of this, you have a lot of different sensor modalities. You have CMOS image cameras, infrared cameras. You have IMUs, inertial measurement units. You have a lot of audio-related connected devices. You have environmental sensors, temperature sensors, optical sensors. And all of the sensors, they feed in this data into the digital world. So it's, again, it's extremely powerful value proposition for tinyML, because you collect data where the data lives, where the data gets produced. So it's very powerful. And again, think about this number: 95% of the oil is there where tinyML is. So that's why fundamentally we believe and we are so passionate about tinyML, because it's, again, the future is there in terms of data collection and enormous value. So if you look at all areas around us, so the tinyML is everywhere, and it creates all these massive opportunities in all verticals where machine intelligence meets the physical world. So you can see some of them here. So it's health and wellness, it's industrial devices, it's lighting type of devices, it's smart home, it's augmented reality, it's phones, it's drones, it's security cameras, again, industrial IoT and machinery. So you have audio signals, you have wearables, automotive, so everywhere, appliances. So basically, any field where you are, you see enormous opportunity for this tinyML, tiny AI, and I'll show some examples later. So where we are in this cycle, I think the good news here, actually there are two good news here, that the opportunity is really huge, as I pointed out before. But I think if you look where we are in the development cycle of this technology, we are just entering this area. So I think we are somewhere here between step 1 and step 2, between kind of building awareness of these products. And we kind of, you can see some initial tinyML products already happening. I do believe that in about 3-5 years, we're going to see tinyML, what people call killer applications, like massive applications. And then probably within a decade or less, we are going to see tinyML everywhere. It's going to be an explosive growth. I think we're already seeing some sign of this. And we'll be talking about trillions of devices. And this is not a science fiction, by the way. So if you already kind of keep in mind how many microcontrollers are deployed around the world, and how many cameras and how many sensors are around there. So we are already kind of in the hundreds of millions today, hundreds of billions today. So very soon we'll be in the trillions of devices. And again, the driving force there is data, collecting data in real time and making it actionable. So that was kind of fundamentals. Let's talk about the numbers. So in general, I'm quite skeptical about market forecasts, because nobody really knows how to predict the future, but they at least give us some kind of guidance where we're going. So this table came out recently from one of the marketing companies, ABI Research. I think what is remarkable here, that they started to recognize tinyML as a separate market segment. And that's actually quite a big accomplishment, given that this field is so young, less than like a couple of years young. So I think what I would like to highlight here, a couple of points. I think one is the growth of these technologies, year-over-year growth of these technologies is enormous. So we're talking about double, sometimes triple number, triple-digit numbers year-over-year. I think average over next decade is about 66%. It's a huge growth potential here. And keep in mind that this is only devices. So I think we're talking about billions of devices here. It's not the total value that is going to be created by tinyML, because to account for the total value, you really need also take into account all the software and services. And if you do so then you're going to see that, and this is just some markets there, we're talking about that the value that tinyML is going to create, the whole economic value, is in the tens of billions of dollars. And those are some of the examples in the logistics, smart cities, infrastructure, and again, double-digit growth, retail, and so on. This came from the Silent Intelligent Research in 2019. And here, I think the point I'd like to make here is, if you look at the value, you saw from the ABI research, they talk about devices only, shown here. But the total value is actually more value is going to be created in the solution and software and infrastructure. And this is not just for tinyML, this is for all IoT. I think that came from the McKinsey report. They look at the total value of IP, but same is also true for tinyML. The majority of the value will be created in the software and services while devices are being deployed here. So basically, I think the point here is that the value of tinyML is going to be distributed across the whole stacks. It's going to be in the hardware, it's going to be in the algorithms, like what Jan described in his presentation, software tools, applications, services. So it's really a massive opportunity for the whole ecosystem, starting from hardware people going all the way to developers and people in the field there. Again, very massive opportunity, and we are super bullish about it. So that was the financial impact of tinyML. But I think what I am personally passionate about tinyML is the impact it's going to make in the social life. And this is just an illustration of this. I think we are going to see more and more of this in the years to come. On the left here, you see the goals that UN developed, like sustainable goals. There are 17 categories there. And if you look at the areas where tinyML and tinyAI is going to make an impact there are like many of them: in the health, in the clean energy, clean water, affordable energy, industrial innovations, infrastructure, smart cities, climate, life on land, and the partnerships, all kind of people to work together. So I do believe that tinyML is going to have a huge impact, not just on the financial side, as I showed earlier, on the business side, but really on our society in general. It's how we live, how we breathe, how we communicate, how we get data, and how we use data for good. So I think the tinyAI for good is really another massive opportunity for this community, and I'm personally really excited about this, like what tinyML is going to offer to us, the technology getting back to people. And this is just one example, which I think sometimes people underestimate, that to train a model, you need to use tons of GPUs, TPUs, and so on. And there was a study done by University of Massachusetts saying that that some models, to train some models, you really need to burn a lot of energy that is equivalent to like carbon dioxide up to 5 times of a lifetime emission of an average car. So basically, while people train models sitting, working from home or sitting in their desk, they burn a lot of energy, and this energy is not free. I mean, it makes actually our planet quite dirty in terms of carbon dioxide and so on. So what tinyML allows, in contrast, and this is the work that was, for example, done by Professor Han and his team at MIT. So you can develop techniques, they can reduce this carbon footprint by a factor of 1,000, like a huge number. So it's, again, by moving your intelligence from the cloud to the edge, you really can make this energy technology so much energy efficient, and that is going to have a massive impact, like on how we do machine learning, how we do AI, and how we live. I think let's kind of speed up a little bit. So we are at 7:30 California time. Next, I'm going to give you some examples. So first example is audio, obviously a popular example. I borrowed this slide with the permission from Sentient on the left, and from ION devices on the right. Those are two startups in California. And what they do, they develop hardware and techniques to do always on voice recognition. And if you look at the numbers are very, very impressive. Like the Sentient NDP 100 chip, which is shown here, very tiny, only 140 microwatts. It's like microwatts. We're not talking about even milliwatts. It's extremely small number. And likewise, AON device is talking about like 100 microamps at the battery. That is also extremely low power. So again, very powerful use case for tinyML in the voice area, in the sound area. So I think we'll see a lot of applications there. So next example, it's also Bosch. Bosch is a MEMS and sensor company, a global leader in the world. They are #1 in the world. So they ship billions of sensors every year. But what is remarkable, and I borrow this from also with the permission from Stefan, the CEO of Bosch and Sensor Tech. They're talking about the AI inside of the sensor itself. Again, what is remarkable here for me is like big giant sensor companies. They're talking about also about putting AI, putting ML, tinyML into the sensor. They're talking about edge AI and the intelligence at the sensor level. Some examples also from Stefan's presentation. So on the left here is a baby diaper. So it's a very analog device. It's probably as analog as it gets. And by putting temperature, pressure, humidity, and other type of sensors there, you can use this machine learning tinyML to get the state of the diaper. I think that's like either clean, dirty, wet, and so on. So another example is going to have also a major impact, especially like this year. We had a lot of fires and wildfires in California. By deploying these autonomous sensors all over the forest or all over the globe, you can really get early detection of what happens in terms of early fire detection, risk evaluation. You can build new forest climate models and so on. So very, very, very powerful. Again, it's going to have a big impact on how we live, how we breathe. Another example, it's predictive maintenance. This one from tinyML. It's a company in the Portland area. So what they do, they put small accelerometers and gyros next to the machines, like motors, for example. And by doing tinyML, they can understand and do some predictive maintenance type of things and look at abnormalities of when this device is going to function normally and when the motor is going to be failing, and that is going to create also quite a bit of value to the customers and save money there. Another example, again, there are so many examples. I won't be able to cover all of them, but just some of them. So this is a recent one that came out from a company in Sweden, Imagimob. So what they do, and you can see the Alexander, the CTO of the company here, doing gestures. So he has a small radar device in headphone, and by using tinyML, they've been able to train a model that can recognize gestures, and then you can do just by using different type of gestures, you can control this headphone device. And they've demonstrated the proof of concept at the CES of 2020 in January, and in a couple of months they will be showing a working prototype of this in-ear headphones at the CES. And that's also a very, very interesting company and the technologies they develop. AR, VR, I think AR, VR from the technology perspective, it's probably the most challenging for tinyML, because you really need to do a lot of sensor type of processing, like visual, do like gesture interaction, sound, and so on. But you are so much constrained what you can do within this form factor type of device. You don't have tons of battery. You need to worry about heat type of issues, and there's not so much computer can do there. So it's really the area where, in my opinion, tinyML is going to shine to solve many of these problems. In fact, some of the known Facebook people, they call this that AR will be one of the killer apps for the energy efficient machine learning. And you can see more details in the Tiny talk by Hans. He did it in March in the tinyML series. But the point here is we're going to see this enormous innovations and breakthroughs in tinyML and applications for AR, VR applications, especially as we're going to see more and more these applications in the next 2 to 3 years. Let's switch gears to vision, and I'll probably finish in about 5 minutes or so. I've tried to. Vision. So why vision is so important? So we humans, we perceive our world by vision. So if you look at the kind of the pie, the breakdown, how we see and how we sense our world, 93% of human perception comes from vision. So vision is very important for us. But in terms of technology, it's been extremely challenging because you need to process a lot of data, big files, a lot of vision, and that's what my team in Qualcomm, we've been able to develop the best and the first to the market solution of always-on vision that does tinyML at a very, very small form factor. You see this tiny device here, so it's less than a dime. I think it's kind of, I'm not sure you can see it here. That's as small as or as big as, actually it's as small as a grain of rice. And what it's a camera type of device or computer vision module type of device. It consists of a sensor and a processor, and it does all analytics in this tiny form factor. Very small size, very low power. It's configurable for different use cases, and very low cost as well. So you see that the use cases again for vision, they're also plentiful. So it's either smartphone, watches, tablets, VR, AR, smart homes, standalone data sensors. It's again in all areas around us where you need vision to develop applications. You can use these devices quite successfully, and it's again fundamentally because it's so small. It's a privacy type of device, and it consumes so little power. It can run on a coin cell battery for many months or years, depending on the duty cycle. It's extremely valuable, extremely high value proposition for this type of technologies, and we already seen a lot of applications for always-on vision. And just some examples shown here. You can, with this small tiny device, you can detect bodies. You can detect them like far away. You can do some motion detection. You can do multiple face detection. You can do gestures. You can train models to detect different type of logos. You can do analytics in retail, like customer engagement time or the state of the shelf. A lot of applications for the vision, and again, simply because vision is extremely valuable for people. Again, 83% of our perception comes from vision. And this is just to show that this is a product. We've been commercializing this already. It's the part number, and this is how it looks like in real time. So it's extremely powerful technology, and there are many applications for vision around us. So just to sum up, and this is the message to take home. I hope I've gave you a little bit. I've given you a little bit of a flavor of what tinyML is. It's basically machine intelligence at the very edge of the physical world with extremely low power, less than 1 milliwatt type of power. Why is this so important? Because it's going to create a lot of enormous value around, and that's because tinyML helps to do data mining and data analytics where the physical world meets the digital world. And as far as the business opportunities are concerned, we already see tens of billions of devices that will be shipped within the next 5 years or so. It's going to create a lot of value in the software and services stack. But please don't forget about the positive social impact, because all these technologies, they will be deployed not just to make company money, but also to make our life better and healthier. And again, we're talking about trillions of devices around us that will be so smart, and they will help us to live within the next 10 years or so, and they will be everywhere around us and always on, and they will be doing jobs seamlessly to us with all the privacy aspects taken care by the design. And when it's happening now, I think we are at the very beginning of tinyML revolution, and if you're interested in kind of learning more, you can ask us a question, or you can go to the tinyml.org website. There is quite a bit of information there, and just join tinyML community. Thank you.
Thank you, Evgeni, for your sharing. Thank you. And if anyone have a question, please post it on the Q&A. And I got one here. Will the computer vision model be compatible with devices like STM32?
Yeah, I think there are several technologies that are being developed for always-on computer vision. Typically, they include a sensor and a processor, and I think some of them will be presented also during this week at the tinyML Asia. So, and specifically talking ST Micro, I believe they did show some demos with also with the computer vision in the past, like at CES 2020. Yes, so the answer is yes, it's compatible. So you can do computer vision with ST Micro type of devices. They all have different type of specs, different type of parameters, different type of memory, different type of power, but all of them are target tinyML vision, always-on vision applications. I think Hynix is another one. They're going to have a video poster, I believe, on Tuesday or Wednesday.
Okay, thank you. And I got one question. And what is the differences in the development stage between the US and the Asia company, especially companies in China? And do you have any suggestions to the companies in China in this field?
Well, I'm hoping that we're going to learn more during this week from the tinyML Asia event. I think that was the whole idea, really, to have this event and to bring the communities. I think what my belief is, I think where Asia is going to bring quite a bit of value to this ecosystem is in the supply chain and the user base area. I think from kind of my personal experience from Qualcomm, we see a lot of companies from China interested in using tinyML for their applications. I'm not going to have names of these companies. That's on one hand, but on the other hand, we also see many research organizations in China and in Asia, in Korea, Japan, Singapore, doing really good research in this area. So I think that's kind of where I see it will be the contribution of Asia in this space is more in application. How do you use this technology? Because basically, tinyML, as I said, it's here and it's now. You have hardware companies providing hardware like ARM, Qualcomm, and others. Then you have companies like Google, Microsoft, and startups like H-Impulse who develop and provide tools and infrastructure for this. So now it's actually time for people to bring all this together and start using this to solve real life problems. And the problems can be anywhere, like traffic, intersections, smart city, smart homes, smart offices. I think Matt gave a good example of COVID control by detecting sound, like how people cough. You can do this. So it's really, and I'm super excited about this when people who start using tinyML to solve problems. I think then where we're going to see this hockey stick, the kind of a massive explosion of tinyML into the application space.
Yeah, thank you. And let's look forward to more interesting discussion during this tinyML Asia.
Right.
And
again,
let me see if there are more questions.
I think we are at the very beginning there. It's good to keep in mind, like if you remember how many iPhones were sold in the first year, if you don't remember, it was less than 1 million during the first iPhone, and now it's in billions. So I think we are kind of at this iPhone 1 generation now. But again, tinyML is going to be everywhere, the hardware and the software and the tools will enable this. Yes, go ahead.
I have one quick question. Is the power consumption of computer vision also less than 1 milliwatt defined by tinyML?
Yes, in general, yes. And I think that was the target for us to develop this technology to be able to have less than 1 milliwatt of power. It depends on several parameters. It depends on ambient light. It depends on duty cycle, how many frames per cycle. It depends on specific application, but generally speaking, yes, I think for most applications, it's less than or close to 1 milliwatt of power.
Okay. How can we different tinyML and quantum ML? Quantum ML. It's a question from.
Oh, quantum, yeah. So I think quantum computing, I think it's still kind of a very interesting research area. It's going to be also very energy efficient, but it's not kind of at the practical level where the general computer is, because today we're talking about digital ML. I think Matt mentioned that there is analog computers coming, analog ML. I think quantum ML, quantum compute is probably going to be like 2-3 generations ahead. There is still quite a bit of fundamental research that needs to be done before it's ready for applications.
Okay, thank you. Thank you, Evgeni, for your presentation.
Thank you. Looking forward to the session tomorrow.
Yeah. So we would like to thank our sponsors who made this event possible. Our premier sponsor, ARM, the Software and Hardware Foundation for tinyML. Edge Cortex, with dynamic neural accelerator architecture and co-exploration engine brings cloud level performance to the edge. SynSense builds ultra-low power sensing and inference hardware for embedded mobile and edge devices. Thank you for all our sponsors. Thank you for making this event possible. And thanks also go to our conference partner, Shanghai AI, a media partner, 智东西 AI in Manufacturing, EET, 机器之星 新视野 and 机械工业出版社. Thank you for our partners. You will find them all listed on the tinyML website at tinyml.org. So thank you for joining us today. And thank you for Jan, and thank you for Matt and for Evgeni for their wonderful presentations. We look forward to seeing you tomorrow.